All right, here we got the final objective of Unit 6. We got Objective 7, graphing square root functions. Okay, now, like when we're graphing anything else, they're all very closely related. So, if you're comfortable graphing a parabola, for example, or an absolute value function or a line, this is going to be very similar. For example, if we introduce a negative to our function, it's going to have the same effect as if we introduce a negative to a parabola. If we introduce something, a multiplier in front of our function, so if it was 1/2 root x, or 2 root x. It's going to have a similar effect like it would on a parabola or an absolute value function, okay, or even a line. So anyways, just relate it to the things that you are comfortable with, and hopefully these graphing sections won't be too bad. And that's going to be the same throughout the whole year. All right, now like it says here, as always, we'll start out with the parent function of our graph. The parent function is the simplest form of our equation. Okay, so f of x equals the square root of x is the simplest form of this equation we can get. So basically this is just y equals the square root of x. For a square root function, it can't get any more simple than that. Now, like it says here, make life as easy as possible by selecting values of x which can easily be square rooted. In other words, we're kind of jumping ahead a little bit. If we're going to graph this thing, well, what does it look like? Well, we don't know yet. Okay, so then how do we graph something if we don't know what it looks like? Well, we can plug in points. We can plug in numbers, right? Stick in stuff for x and then solve for y. Now, since f of x equals root x, and we can replace this with y, basically our y value is the square root of x. So when we make our table over here, we got these x values, and then these are essentially our y values. So you can put a little y there if you want, because that's like our y values. Okay, so when we plug something in for x, what do we get for y? So we're just going to make a table. All right. Now, normally if we're going to plug in some numbers, we might plug in a few negatives, a few positives, and usually 0 is a good number to plug in. So should we plug in, maybe -1, -2, -3, 0, and then +1, 2, and 3, something like that? Well, no, because look at our function. What does our function have? Well, it has a square root in it. So what can we plug in there? Now, maybe a better question to ask is what can we not plug in under a radical, under a square root, or any even root? Well, we can't plug in negative numbers. Okay, so then we can forget about all those. And then also, if I'm going to plug in numbers, do I want to plug in something like 2 for x here? Well, what's the square root of 2? I don't know, some decimals, 1 point something. Okay, so we don't want to plug in numbers that don't work out nice. So basically what we want to do is plug in perfect squares here. Now, it's not always perfect squares, but it's whatever gives you a perfect square under the radical. For example, in the next equation, well, I don't want to just plug in a perfect square like 4, because then I get the square root of 6, which doesn't work out nice. So plug in numbers that work out nice. So for this first table, then they pick the numbers for us. They pick 0, 1, 4, 9, and 16. Now, why did they pick those numbers? Well, those are all perfect squares. So they give us whole numbers for answers, and that's what we want. Those are easier to graph. Okay. All right. Notice some key features about this function. What's the smallest number you can take the square root of? Well, they already kind of filled it in for us, but the smallest thing we can take the square root of is 0. Okay, because we can take the square root of any positive number. We don't want to work with negative numbers. We're not working with imaginary numbers here. And then what is the square root of 0? Well, that's also 0. Okay, which is why in our table, when we plug in x is 0, we get y is 0. So then this thing has like a starting point. It's not really a vertex, more of a starting point at 0, 0. So then that's our first point. Okay, we can plot that point there. And then, like it says, the graph is ever increasing, but at a slower and slower rate. So what does that mean? Well, basically, it's ever increasing because was there a biggest number that we can take the square root of? No, as long as we can multiply a number by itself, we can take the square root of that product. So anyways, this thing goes on forever, but at a slower and slower rate, because you'll notice the x's are getting bigger kind of quickly. The next one will be 25, then 36, then 49, because again, we're plugging in those perfect squares. Okay, but then what's happening to our y values? Well, they're only going up by 1, because this is 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the y's are only going up by 1, but the x's are getting bigger and bigger more quickly. Okay? All right, so anyways, enough talk. Let's actually plot these points. Like we said, these are our x values, these are our y values, and we're picking x values that are perfect squares so that it works out nicely. So we can plug in 1, 1, we plug in 4, 2, we can plot that. 1, 2, 3, 4, 1, 2. And then 9, 3, we could probably do that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3 is going to be right about here. But as you can see, we're going to get off the graph pretty quickly because these x values, they get large real quickly. Okay, but that's okay. We got our starting point here. We know our x values don't go over here because we can't plug in negative numbers. We got this little thing, and when we draw this curve, now make sure it does have a little bit of a curve to it. Okay, it's going to look something like that. So it kind of looks like half of a sideways skinny parabola. Okay, and then that's what all these graphs are going to look like. They're going to look something like this. Maybe they'll be a little bit wider, maybe they'll be a little bit narrower. We can always shift it around, but all our graphs are going to basically have this same shape for any square root function. Okay, and like I said, keep in mind the way a parabola works. That's one of the things that we graph the most. A parabola, y equals x squared. What's that going to look like? Well, something like this. And then if it's, y equals negative x squared, when we introduce a negative, what does that do? Well, it flips it. What if we had y equals x squared plus 1? If we add a 1 at the end, well, then that moves it up 1. If we put the plus 1 inside the squared part, so x plus 1 quantity squared, well, then that would move it left 1. All that same stuff applies here. So if you know how parabolas work and how to graph those really well, this shouldn't be hard now that we know the shape. Okay, let's look at the second example. All right, set this up more actually. All right, and like we just talked about, the shifts work just like all other shifts that we've worked with. Again, select the values of x, which will make the square root process easy and clean. So we want to graph this thing. Okay, so then how do we graph this thing? We kind of know what it looks like, and then hopefully we know what the shift is going to be. If this was, x plus 2 quantity squared, like we kind of just talked about actually, how would that move my parabola? Well, x plus 2 is going to move it to the left 2. So this is going to do the same thing. So we're guessing it's going to look pretty much just like that, just shifted to the left 2 units. Okay, but let's make sure. In other words, let's make a table and plug in some points. We don't have to do this all the time, but we're still new at this. Let's make sure we're doing it right. So I want to make a table with x and y values. I don't need to put f of x or root x. We'll just put x and y. Okay, and then when I plug in something for x, what do I get for y? Okay, now what do we want to plug in for x? Now remember, what's the smallest thing that I can take the square root of? 0, and the square root of that is 0. Okay, so do I want to stick in 0? Well, no, because if I stick in 0, I get 2 under the radical. But what's going to give me a 0 under the radical? Sticking in what for x? Well, negative 2. That's going to give me 0 under the radical. What's the next smallest perfect square? So look up at the table up at the top of your page if you need to. After 0 would be 1. Well, what's going to give me a 1 under the radical? Plugging in negative 1. In fact, let's work these out as we do it. If I stick in negative 2 plus 2 is 0. Square root of 0 is 0. If I stick in negative 1 plus 2 is 1, and then the square root of 1 is 1. Okay. What's the next perfect square I want to plug in? Okay, well, I want to get a 4 under the radical next. What's going to give me a 4 here? Well, plugging in 2 for x. Okay, and then if I plug in 2 plus 2 is 4, the square root of 4 is 2. Okay, next, what's the next perfect square? So again, we're pretty much just trying to get these numbers under the radical. In fact, those are pretty important numbers. Let's highlight those. That's something we're going to come back to a lot. All right, next I want to get a 9 under the radical. Well, what's going to give me a 9 under this radical? In other words, what plus 2 is 9? 7. So if I plug in 7 plus 2 is 9, square root of 9 is 3. So you can see your y values should always be going up by 1, and your x values, well, kind of depends. Okay, and then one more, we can squeeze it in. If we wanted to get the next perfect square would be 16. Well, then to get 16 under the radical, I'd have to plug in 14 for x. 14 plus 2 is 16. The square root of that is 4. Okay. All right, now are we going to plot all these points? Oh, no, because they're not all going to fit on our graph. We'll put as many as we can. All right, so let's see. We've got the point negative 2, 0, which, yeah, that is just shifted left 2 of our previous graph. Then we got negative 1, comma, positive 1, which is also shifted left 2. All the points should just be shifted left 2 from this graph to this graph. 2, 2. Yeah, that's also shifted left 2 points. And then one more, 7, 3. Yeah, that's also shifted left 2. So yeah, everything was just shifted left 2 units because of that x plus 2 there. And now we can draw our curve. Again, I know it's kind of hard to make a curve when it's so flat, but do your best. That's not my best. That's okay. Anyways, our curve should look about like that, which, like we said, looks like this curve just shifted left 2 units, because anytime we add 2 to our x value in our function, it's going to shift it left 2. Whether it's a parabola, square root function, absolute value function, doesn't matter. Okay? All right, so the graphing part, not that hard. Once we know what the shape is, we need to find where's that starting point. Okay, well, what's going to give us 0 under the radical? That's basically our starting point. And then we get that general curve. Okay, now here, at the bottom of the second example, they're asking us some examples about our graph. Okay, so what is our domain? Okay, in other words, what can x be? Well, looking at our graph, anything from here over. Okay, in other words, what can we stick in for x in this function? Well, the smallest thing I can get here is 0, and that's going to happen when x is -2. So it could be anything -2 or bigger. Okay, so there's 2 ways to write that. We can say x has to be greater than or equal to -2. Okay, that's inequality notation. Or we can put it in interval notation. X can be anything from -2 to infinity. Yes, we're including -2, so we want brackets around that. We can never include infinity, so we want parentheses around that. Okay, so then there's the domain. What's the range of my function? Okay, now the range is always easier to look at your actual graph. And what can y be? Well, the lowest y value is here, that's my little starting point. And then this thing is going over and up. And when does it stop going over and up? Okay, because again, I know it's going over a heck of a lot faster, but it's going up forever, right? It can keep going up forever. So then the range is anything from 0 to positive infinity. So then x is greater than or equal to 0. Or we can say it goes from 0 to infinity. And then, yeah, I am including 0. That is a solid circle. So we'll put brackets around the 0. Okay. All right, next, what's our x-intercept? Now, as always, to find the x-intercept, we can plug in y 0, but just look at our graph. Where does our graph hit the x-axis? Well, right there at -2, 0. Sometimes you might have to solve for that algebraically, but if it's on your graph, well, great. Let's just use that. Where's our y-intercept? Right about there, which is a little bit bigger than 1. Okay, so this one, we can't just use the graph, we have to actually solve algebraically. Okay, so then to solve for the y-intercept, we always want to plug in x is 0. So then we're going to get y equals the square root of 0 plus 2, which is y equals root 2, which is a number. And then so we can just leave our answer as our y-intercept is at 0, comma, root 2. And yeah, root 2 is, 1 point something. We can get an approximation if we punch it in a calculator, but we don't want an approximation. We want the exact answer. So the exact answer is at 0, comma, whatever the square root of 2 is. Okay, so just leave it like that in your answer. No need to get a calculator. Okay. All right, next, open interval where our function is either increasing or decreasing. So first we need to figure out, well, is it increasing or is it decreasing? So as x gets bigger, is y getting bigger or is y getting smaller? Well, obviously, as x gets bigger, y is getting bigger. Okay, it's doing that slowly, but it is increasing. And then where's our function increasing? Well, basically everywhere, right? From when it starts to when it finishes. So from -2 to, goes on forever, so from -2 to infinity. Now remember, it's the open interval, okay, because it can't be increasing or decreasing at an exact point. It's always between 2 points. Open interval basically means we want parentheses around both of those parts. Okay. All right, and then the last part, this is a new part, the average rate of change for our function on this interval. Okay, so that means from x values of -1 to 7, what's the average rate of change? Okay, now hopefully you've heard the term rate of change before. Rate of change basically just means the slope. So basically they're asking for the slope, because if they say, what's the rate of change on your function? Well, since the steepness of this curve is changing, it's getting flatter and flatter, there is no constant rate of change. If it had a constant rate of change, it would be a line. So for any curve, we can find the average rate of change by finding the slope between 2 points. So that's what we want here. Let's kind of make a little note of that. They just want the slope between 2 points. Okay. And then which 2 points do they want the slope between? Well, -1 comma something and 7 comma something. Okay, because here they're saying, I want to know the slope between the points with x values of -1 and +7. Whoops, I didn't mean to put 0 there, sorry. I put a question mark on both of those. Okay, so -1 comma something and 7 comma something. So if I know what those 2 points are, well then I can just find the slope between those 2 points. Okay, so let's see. 2 ways to do that. One, plug in -1 to your function, which we already did, and we get y as 1. So then -1 comma 1 is one of our points. And then 7 comma, in other words, when I plug in x is 7, what do I get for my y value? Well, we already did that as well. When I plug in x is 7, y is 3. So basically just plug those into your function. We get those 2 points. And then I want to find the slope. Okay, now one way to do that is to use the slope formula, which we probably haven't used in a while, but it's just y2 minus y1 over x2 minus x1. Okay, that's our slope formula. Let's call this, this was the first point we wrote down. We'll call this x1 and y1, x2 and y2. Sorry, I barely have room to label those things. Okay, and it doesn't matter if you switch them. This could be x2 and y2 and x1 and y1. Doesn't matter, you'll get the same answer. Okay, and then when we plug those in, y2 minus y1 is going to be 3 minus 1 on top over x2 minus x1 is 7 minus -1. Simplify that, 3 minus 1 we get 2 over 7 minus -1, so the opposite of a negative would be plus, so 7 plus 1 we get 8. And then that reduces to 1 over 4. Okay, so then the average rate of change is 1 over 4. It means we're going up 1 and over 4 on average between those 2 points. Okay, now another way to do that, if your points are on your graph, especially. If they weren't, we couldn't do this, but just look at the points on our graph. We got -1, 1, so that's right here. I'm going to put a big red point on there. And then 7, 3, that's over here. Well, what they want is the slope between those 2 points. Let's use a straight edge of some sort. I'll just use this notepad here. So basically they want the slope of that line, which, especially because I kind of messed up on my curve there, it almost looks like it's right on top of it, but if we zoomed in close enough, it wouldn't be. Another thing you can do to show a more accurate drawing is always, you can go and use Desmos. Plug this function into Desmos. You can type it with f of x or with y. You can just put y equals the square root of x plus 2. And then you'll see this function. And then you can draw the line connecting these 2 points, and it'll show you a better graph. But anyways, I want to find the slope of that line. So how do I go from this point to that point? Well, I go up 1 over 1, 2, 3, 4, up 1 over 1, 2, 3, 4. So then, yeah, the average rate of change is up 1 over 4. Now, really, if I was going from this point to this point, I'd just say up 2 over 8 and reduce it, which is what we ended up doing in our equation anyways. But yeah, the average rate of change is just the slope between 2 points. And they're going to give you the x values of those 2 points. Okay? So again, you can use the slope formula, or if both points fit on your graph, you can just look at the rise over run. How far up do you go and how far over do you go, and then reduce that. Okay, so that's the first page. And then we've got the back side of the notes as well. So next, we want to graph 3 minus the square root of x. Now before we start, I'm sorry, this isn't on the right spot. Okay, so we got y equals 3 minus the square root of x. Before we start, let's get this, looking a little more familiar to us. Normally we start with y equals instead of f of x. We'll do that. And then, well, I don't have the plus 3 in the beginning. Normally we'd write it something like this, negative root x, then plus 3 at the end. Okay. All right, and then how are we going to graph this thing? Well, we're still kind of new at these. Let's make a table. Now, before we make our table and actually fill in the values, what do we expect to happen? Let's do the easy one first. What's this plus 3 at the end of my equation going to do to my graph? Well, it's probably going to move it up 3, right? Because that's what it would do to a parabola or an absolute value function or a line. And then what's the negative going to do to my function? Well, normally that flips it, right? So then instead of being the top half of a sideways parabola, it's probably going to be the bottom half. So it should be swooping downward. Okay, so let's see if that's correct. Excuse me. All right, so we want to plug in values under our radical that give us perfect squares. Now, since there's nothing else under the radical other than x, we can actually plug in our perfect squares. I can plug in 0 and 1 and 4 and 9, and we'll stop there because that will get us off the graph anyways. Okay, and if I stick in 0, what do I get? Well, if I stick in 0, the square root of 0 is 0. The opposite of that is still 0. Plus 3 is 3. So yeah, we're starting at 0, 3, just like we thought. It's shifted up 3 units. Okay. Next, if I stick in 1, well, the square root of 1 is 1. The opposite of that is negative 1. Plus 3 is 2. Next, if we stick in 4, well, the square root of 4 is 2. The opposite of that is negative 2. Plus 3 is 1. So now instead of our y values going up by 1, well, now they're going down by 1. And then last one, we stick in x is 9. Well, the square root of 9 is 3. The opposite of that is negative 3. Plus 3 is 0. So this is 7, 8, 9 would be out about here. And now I can draw my curve, which, yeah, rather than the top half of that sideways parabola, it's kind of looking more like the bottom half. I can't seem to draw a smooth curve between those 2 points. Anyways, it's going to look something about like this. So yeah, just like we expected, it was shifted up 3 because we started at 0, 3, and then the negative flipped it upside down. Okay, and then we'll just go through these other questions. What is the domain? Well, x can be anything from here over, so from 0 to infinity. I'm going to write it in interval notation just because that's the way that sometimes it's required on the test. Actually, we'll put it both. X is greater than or equal to 0, or from 0 to infinity. Yes, we're including 0, so brackets around the 0. What's the range? What can my y values be? Well, since it's going down forever this time, what's the highest point? Well, positive 3, so it goes from 3 to negative infinity. So we can write that 2 different ways. We can say that y is less than or equal to positive 3. Or in interval notation, now remember with interval notation we always want the smallest number first, so we can say it goes from negative infinity up to positive 3. And brackets around the 3. Okay, what's my x-intercept? Okay, well, just look on our graph. X-intercept, well, that was down here, and we didn't finish writing it. But y is 0 and x is 9. Okay, we don't need to do it mathematically. We got lucky there. The x-intercept is just 9, 0. What's my y-intercept? Okay, good. We don't have to do any work here either. It's just right there at 0, 3. All right, open interval where my function is, well, first of all, what is it doing, increasing or decreasing? So here as x is getting bigger, y is getting smaller, right? Our y values are going down, so it's decreasing. And then when is it decreasing? Well, on this entire graph, which goes from 0 to infinity. Sorry, negative infinity. And we do want to put the 0 first because we're talking about the x values. No, so I'm sorry, I was right the first time. It is 0 to infinity. I got my x's and y's mixed up for a brief second. And again, open interval always has parentheses, not brackets. Okay. All right, next, scoot this up a little bit. What's the average rate of change for our function on the interval between x values of 0 and 9? Okay, in other words, what's the slope between 0, something and 9, something? Well, what are my 2 points here? 0, what? Well, we already plugged that in, and we got 0, 3. And 9, what? Well, 9, 0. Okay, so then what is the average rate of change there? Okay, now we can use the slope formula, or just think, because I want to find the slope of this line. Right there. So what's the slope of that red line? Well, I'm going over how far and down how far. Now normally it's rise over run. So this time, since we're going down and over, I know it's going to be negative. And then I'm going down and over how far? Well, I'm going down 1, 2, 3, and then over 9, because we know that point's at 9, 0. So we're going down 3 over 9. So we get 3 over 9, which reduces to negative 1/3. So on average, I'm going down 1 over 3. down 1 over 3, down 1 over 3, down 1 over 3. Yeah, that works. Okay. So again, you can use the slope formula with these 2 points, okay? Or just look at the rise over run. Again, if the line fits in your graph, it's probably easier to just look at the rise over run. Okay, and we won't do it both ways because we don't have a ton of space. All right, almost done. All right, last one, graph dysfunction. All right, so first of all, let's think a little bit. Where's my starting point going to be? What's the x plus 1 do? That's going to move me left 1. What's the negative 2 do? It's going to move me down 2. So I'm expecting my starting point. I'm going to go ahead and graph it because I'm confident. It's going to be left 1 and down 2. All right, and then just verbally, what's the negative going to do to our graph? Well, this should flip it over, so it's going to be kind of like this one again, opening where it's getting smaller rather than getting bigger. And then what is the 1/2 going to do? Well, we haven't seen that yet, but it's probably going to either make it, a little bit flatter or a little bit more of a curve. Okay, so let's see which one it does, and we'll figure that out by plugging in points, because this is a good type of graph to plug in points for, so we don't have to do too much in our head. Okay, so again, I want to make a table with x and y values. Okay, and then remember, we want to plug in whatever gives us perfect squares under the radical. Okay, so we want to get 0, 1, 4, and maybe 9 under the radical. And we can stop there because we can't fit any more points than that on the graph anyways. Okay, what's going to give me 0 under the radical if I stick in what for x? Negative 1. If I stick in negative 1, well, negative 1 plus 1 is 0. The square root of 0 is 0 times negative 1/2 is still 0. Minus 2 is negative 2. So our first point is negative 1, negative 2. Okay, good, we were correct. Next, I want to get 1 under the radical. What's going to give me 1 under the radical? Well, plugging in x is 0. 0 plus 1 is 1. The square root of 1 is 1. Times negative 1/2 is negative 1/2. And then minus 2 is negative 2.5. And we can just write a mixed number, that's fine. So negative 2.5. Let's go ahead and plot these as we go along. 0, negative 2.5, right about there. All right, next, what's going to give me a 4 under the radical? So what plus 1 is 4? Well, 3. Okay, and then if I stick in x is 3, 3 plus 1 is 4. The square root of 4 is 2 times negative 1/2 is negative 1. Minus 2 is negative 3. So we get the point 3, negative 3. Okay. So here, rather than my y values going down by 1, well, now they're going down by 1/2, which is that many. So this number basically tells us how quickly or slowly our y's are getting bigger or smaller. Okay, so they're going to get bigger or smaller that much. So if this was a negative 2 in front, well, then my y's be going down by 2. But since it's negative 1/2, they're going down by 1/2 each time. All right, let's do one more. What's going to give me a 9 under the radical? Well, I want to plug in x is 8. If I plug in x is 8, I get 8 plus 1 is 9. The square root of 9 is 3. 3 times negative 1/2 is negative 1.5. Minus 2 is negative 3.5. So again, it's going down by 1/2. So when x is 8, which is 1 past this point here, right about here, we get negative 3.5, which is going to be right about here. Okay, and then we get an even flatter curve, so this might look more like a line than the other ones even did, but try to make it have a little bit of a curve to it, if possible. Again, looks kind of like a line, but it should have a slight curve to it. Our graph's going to look something about like that. So again, it was shifted left 1, down 2. We know it was, flipped over, and then the 1/2 made it a little bit flatter. Okay, a couple questions, then we're done. Identify the following. What's our domain? Well, that's pretty easy. X can be anything from here over, so anything from negative 1 and bigger. So we'll just write in interval notation. It could be anything from negative 1 to infinity. And yes, we're including negative 1. What's my range? Well, my y, remember, we went the smallest number first, so they go down forever. They're getting small slowly, but they do go down forever. So it goes from negative infinity up to, what's my biggest y value? Well, my starting point, which was at negative 2. And we are including negative 2, sorry, so brackets around that. All right, and then the last one, the average rate of change for x values between from 15 to 99. So when x is 15 to when x is 99. Obviously, this stuff does not fit on our graph, so here we're going to want to use the slope formula. Okay, so then what are our 2 points that we're going to find the slope between? Well, 15 comma something and 99 comma something. Okay. First of all, what are the y values for these 2 points? Let's see, let's plug in 15 to my function. If I plug in 15, 15 plus 1 is 16, so good, that's a perfect square. Square root of 16 is 4, times negative 1/2 is negative 2, minus 2 is negative 4. So that would have been our next point. Okay. And then next, if I plug in 99, 99 plus 1 is 100. Good, that's another perfect square. Square root of 100 is 10, times negative 1/2 is negative 5, minus 2 is negative 7. Okay, great. And then now I want to use my slope formula, which we wrote down earlier, is y2 minus y1 over x2 minus x1. Okay, let's label these points. It doesn't matter which one's which. We'll just go x1 and y1 on top, x2 and y2 on bottom. You're welcome to switch those. You'll get the same answer. Okay, and if we work that out, let's see, this is going to give us what? y2 minus y1 is going to be negative 7. Careful with your negatives here. Minus negative 4 over x2 minus x1, 99 minus 15. Okay, and then that's going to give us, let's see, that's going to be negative 7 plus 4. Negative 7 plus 4, we get negative 3 over 99 minus 15, we get 84. Okay, and then we can reduce that, and we're going to get negative 1 over 28. So then that's the average rate of change between those 2 points. In other words, if we drew a line from this point to that point, the average rate of change would be we'd go over 1, down 1 and over 28. All right, and that wraps up the last set of notes for this unit.